If you want to grasp how a giant neural network functions, you have to understand this tiny building block first.
The perceptron is such a neat concept. You can think of it like a very simple biological neuron, metaphorically. Dendrites get signals in, the axon decides whether to fire a signal out. The perceptron is the mathematical model of that basic decision. It's essentially a simple linear classifier that outputs one of two values, binary.
And the math is pretty straightforward, isn't it? It just calculates a weighted sum of its inputs, adds a bias, 5f the x, WTX plus W$.
Exactly. That weighted sum, 5 and x, is then fed into a really simple activation function, a step function usually. If 5x is greater than 0, it outputs 1, it fires. If it's 0 or less, it outputs 0, it stays silent. It's the simplest possible artificial neuron.
For all that elegance, the single perceptron famously hit a wall. There was a classic problem it just couldn't solve.
Yes, and that failure was really important historically. A single perceptron, because it's strictly linear, cannot solve the XOR problem. XOR is a basic classification task, but it requires a nonlinear separation boundary. The perceptron's inability to do this showed the limits of a single layer.
Which led directly to the next big step, right? The multi-layer perceptron, the MLP.
Precisely. The MLP overcomes the XOR problem by introducing hidden layers between the input and output. And instead of just being a simple classifier with a step function, the MLP is trained to optimize a more sophisticated function, typically the log loss function. And it does this using a technique called Stochastic Gradient Descent, or SGD.
Okay, stochastic gradient descent. That sounds like heavy jargon. What does that actually mean in simpler terms for someone listening?
Right, it sounds intimidating. But SGD is just a really clever and efficient way to teach the network. Instead of looking at all the training data at once, before making an adjustment, which would be incredibly slow, you look at small, random batches of data. That's the stochastic part. Then, based on the error for that small batch, you gently nudge the network's weights. You adjust them step by step in the direction that reduces the error the fastest. This is the gradient descent part, going downhill on the error curve. It's how these huge networks can learn efficiently from massive data sets. And the MLP was the architecture where this process really proved its power.